two reactants react. Who wins, the substitution product or the elimination product? When one bromobutane reacts with sodium hydroxide, a substitution product forms as well as an elimination product. Which product is the major product and why? Remember, in a substitution reaction, a nucleophile reacts at the alpha carbon, but in an elimination reaction, the nucleophile reacts at the H bonded to the beta carbon. You can think of this as the alpha carbon and H bonded to the beta carbon as competing for the nucleophile. To help us determine who wins that competition for the nucleophile, stop the video and read these factors. Elimination is usually favored over substitution. So let's compare the alkyl halide type, primary, secondary, tertiary, to the size and strength of a nucleophile. So stop the video and read the factors which determines whether substitution is favored or elimination. This table ranks the nucleophiles by strength. The nucleophile strength matches the base strength except for the halides. The size of the nucleophile also determines whether the substitution product forms or elimination product forms. So stop the video and answer question A. So here are the large nucleophiles. If the R group has 2 carbons or more, consider that large. This table ranks the leaving groups from best to worst. So far we've looked at these leaving groups. Those leaving groups are found in alcohols or alkyl halides. Later in this course we'll look at other functional groups which can also behave as leaving groups. We've looked at the factors that determine whether a substitution product forms or elimination product forms. So stop the video and answer these questions. The answers are: so remember, if a nucleophile reacts at the alpha carbon, the substitution product forms. If the nucleophile reacts at the H bond, the beta carbon, the elimination product forms. So note that the alpha carbon is a better electrophile than the H bonded to a beta carbon. However, it's more difficult for a nucleophile, especially a large nucleophile, to access the alpha carbon. A nucleophile has easier access to the H bonded to the beta carbon. We looked at this reaction earlier. If you predicted the substitution product is the major product, you are correct. 1-bromobutane is a primary alkyl halide. The hydroxide ion is a small, strong base, so the substitution product is favored. So let's practice. Draw the structure of the substitution and elimination products of each reaction. Then predict whether the substitution product or elimination product is the major product of each reaction. So here are the answers. First, I'll draw the substitution and elimination products. For the first reaction, the substitution product is the major product. For the second reaction, the reactant is a secondary alkyl iodide, and the nucleophile is a strong base. So the elimination product is favored. 2 possible elimination products form. The major product will be the more stable alkene. Practice makes perfect, so stop the video and draw the substitution and elimination products of each reaction, then determine which product is the major product. So here are the answers. First, let's draw the substitution and elimination products. Now let's identify the alkyl halide type. Next, let's identify the nucleophile as big or small, strong or weak. So based on the alkyl halide type and the size and strength of the nucleophile, the major product for each reaction is... Refer back to slide 4 for the factors that determine whether the substitution product is favored or elimination product is favored.